Are problems sneaking into your business without warning? What if you had a way to spot the errors that went unnoticed, or an early warning system that alerted you before they cost you money? Well, that's where control charts come in. In the next few minutes, I'll show you how the simple graph can save you time, money, and stress by catching issues before they spiral. In this video, you'll learn about what control charts are and why they matter, how to build and read one step-by-step real-world examples, yes, with pizza, show their power, and how to use control charts to boost quality in any industry. What is a control chart? Think of the control chart as a health monitor for your business or process. It tracks results over time and tells you whether changes are just random noise or something you need to fix fast. But how does it do that? Well, the x-axis shows time or the sequences of observations. The y-axis shows the measurement you're monitoring, like delivery time. The center line represents average performance. More importantly, you need to keep the upper control limit, UCL, and lower control limit, LCL, in mind. Think of them as guard dogs. As long as your dataset stays within these 2 points, the process is in control. In case your dataset falls outside these limits, well then you've got a problem on your hands. Before we get into how to make a control chart, you need to know how to spot the different types of variations. There are 2 kinds, common cause and special cause variation. Common cause variation is the natural randomness in every system. In our case, the pizzeria manager might notice slight variations in raw materials or temperature. Meanwhile, special cause variation is the real deal. It's the unusual that throws the entire process off, like a machine malfunction or a new staff member making mistakes at the pizzeria. Now that's out of the way, it's time to learn how to make a control chart. How to make a control chart. Here are the basic steps. Don't worry, I'll go through them all using our zero defect pizzeria example. Step 1, collect the data from the process. Say the manager wants to track pizza baking time so he can serve them all of the best quality. The manager knows that their margarita pizzas need to be baked for a full 10 minutes in the oven for perfection. Any less and it's undercooked, any more and it's burnt. And so he'll want to see if the baking times fall within that limit. He'll time 5 random pizzas every day for the next few days during lunch rush. Step 2, calculate control limits. This step involves a bit of statistics, but don't worry, you don't need to whip out your math books. Software tools like Excel can do it for you. Typically, the limits are set at +3 standard deviations from the average. Let's say the average bake time is 10.52 minutes, with a standard deviation of 0.8. Upper control limit UCL is equal to 10.52 plus 3 multiplied by 0.80 is equal to 12.93. And lower control limit LCL is equal to 10.52 minus 3 multiplied by 0.80 is equal to 8.10. These are your warning lights. Step 3, plot data on chart. Once you have your limits, you can plot your chart. Every data point goes up there. Put time or day on the x-axis. Put bake time on the y-axis. Plot each day's average. Add your center line, UCL, and LCL, and voila, you're done. Step 4, study the graph for trends, and this is the most important step. You need to interpret your findings to make sure the process actually accounted for something. The goal isn't just to see dots, you want to see trends. Watch out for a point outside the limits, Rule 1. A run of 9 points on one side of the center line, Rule 2. A steady climb or drop, Rule 3. Weird zigzags or shifts, Rules 4 to 8. These are called the Nelson rules. They help spot real issues even before limits are broken. Example, in our pizzeria example, the upper and lower limits are 11 and 9 minutes respectively. Since there's no point outside of the limits, it means that the entire process is stable, aka the manager is serving his customers perfectly baked, mouth-watering pizzas. So there's nothing to worry about. And so the manager does not need to take any extra measures. However, if there was a point spike above the upper limit, that would have been the special cause variation. In that case, the manager would have had to look into the ovens. Maybe someone was leaving the pizzas in for too long, or maybe there was something wrong with the timer. Remember, a special cause variation needs to be taken seriously before customers start complaining or the business shuts down. Remember, early action equals happy customers. But control charts do more than catch errors. They help your whole system run smoother. Here's how. 1. Early warning system. Catch problems before they explode. You see changes in the data before the damage hits. If our pizza chart shows baking times creeping toward 11 minutes, you fix the timer before pizzas burn during the weekend rush. 2. Real-time monitoring. Track how a process behaves over time, not just one-time snapshots. You see that every Friday lunch shift has slightly longer bake times. That's a trend, not a fluke, and it needs attention. 3. Visual clarity for everyone. Charts speak clearly, whether you're a manager or frontline staff. In our example, the kitchen team sees the red control limits and knows instantly when something's off. No need to explain with numbers. 4. Continuous improvement. Even when things look fine, charts help spot ways to improve. Your pizzas are within limits, but the chart shows random swings. You tweak oven settings to get even tighter control. Result: less waste, more efficiency. 5. Better decisions. You don't just react, you respond based on evidence, not gut feelings. A customer complains about a pizza. Instead of guessing, you check the chart. It confirms a spike on Tuesday, so you fix the root cause. 6. Waste reduction. By catching problems early, you avoid rework, delays, and wasted materials. The dough was slightly overhydrated for 3 days. The chart helped spot it before dozens of pizzas had to be tossed. Limitations. That said, before you use the control chart to make your life easier, there are a few limitations. For starters, you do need some knowledge about statistics. You'll need to understand terms like standard deviation, control limits, common cause, and special cause variations. Skip out on this and you'll end up with just a fancy chart, and that's where the second limitation comes in. If you misinterpret the graph, you'll make the wrong decisions. Finally, the chart's not good for high variability processes. Best practices. Use clean, consistent data. Your chart is only as good as the data you feed it. Calibrate measuring tools. A faulty thermometer can skew every reading. Make sure tools are accurate. Train your team to read charts correctly. Everyone should know what a red flag looks like and what to do about it. Combined with other tools like Pareto or fishbone diagrams, charts show what went wrong. These tools help you find why. Review and update charts regularly. Don't set and forget. Your process changes, so your chart should too. However, remember, a control chart is still good for detecting problems and continuous improvement. How would you use a control chart to help your business? Let us know in the comments below. If you found this helpful, hit that like button and subscribe for more real-world quality tools to optimize your business.